Hello, and welcome to 5 Minute Math. My name is Aaron Daffern, and today we are looking at the fourth grade mathematics STAAR test from 2024. You can take a look at the item analysis report for the entire state of Texas using the QR code or the tiny URL you see on the screen. You can also jump ahead to any item using the timestamps you see on the screen or the bookmarks you see at the bottom of the video. For number one, we are looking at representing data. This is standard 4.9a, and we have a data set here. We need to match this with a dot plot, and we just need to find the dot plot that matches the correct one. So let's do this. Let's make our own dot plot here, and I'm just going to draw it over here to the side, and I'm going to kind of match what they have here, except I'm just going to draw the whole numbers. So 52, 53, 54, 55. Let's put 56. I'll use a different color. Let's get these little hash marks here in between. So that's 52 and a half, 53 and a half, 54 and a half, 55 and a half. And let's just see what we have here. So I'm looking, I see two 53 and a halves. So I'm going to put those right here. There's one, there's two. Looking at this next one, 54 and a half. It only looks like there's that one. So that's going to go right here at my 54 and a half. When I'm looking at 55, I also see two. So I'm going to put those right there. One, two. We want to make sure they're spaced out evenly with the other ones. I've got two 52 and a halves. So it looks like I've got quite a few halves, which may or may not be confusing, even though they're all marked on the answer selections. I didn't mark mine, but the answers have theirs. And then I need a 54, so that's going to be right there. So right, this is the shape that I'm looking for, right? I'm looking for 2, 2, 1, 1, 2. And we notice that A at least has the 2, 2, 1, 1, 2. Let's make sure they're in the right spot. So 52 and a half, yes. I've got a 53 and a half, yes. 54, 54 and a half, yes. And then 55. So A looks good. Let's check B. Well, B's not going to work. It's 1 all the way across. So they just did one of each number rather than one for each time that number shows up. And C just doesn't have that same shape. It's got the 2, 1, 2, 2, 1, right? So the problem is right here. This 54 and the 53 and a half, different than mine, right? So creating your own is going to be helpful. And then I don't have the correct one here. I've got the 1, 2, 1, 1, 2. And so they don't have enough at 52 and a half. But other than that, it looks pretty good. So it's a very, very close one on C and D. But our answer here is A. Now, let's see how we did across the state of Texas. This was the easiest. The easiest question on the entire test, the first easiest. So we'll rank each of these items throughout the test as the fourth hardest or the third easiest, but this is number one. We had 83% of our students get this one correct. And then our other answer choices, it's just random background noise. 4%, 7%, 6%. So 83% of our students get this. We're actually pretty good in the state of Texas at any of our data standards in grades 3, 4, 5. For the most part, we do pretty good with data analysis. So let's move on to our next item. Number two, we are looking at the base 10 number system. So this is going to be standard 4.2a. And as you'll notice, we've got to do three correct answers on this one. So this is a hot spot, and we have to get three correct answers. And so we need to find one digit circled, one digit underlined, and the circled is 10 times the underlined. So let's do this. The circled equals 10 times the underline. So that's what it's saying here. We need to turn this sentence, in which numbers is the value of the circle digit 10 times the value of the underlined digit. So what we can do then is we can write each of our numbers underneath here, right? So let's just write them in order. So let's start with this first one. 5,582. Okay, so there's my underline, and there's my circle. So over here off to the side, what I'll say is I will say this 5, and I need to know the value, right? So this 5 is really a 500. This other 5 is really a 5,000. So let's put those values, since we're talking about value and value, into this equation up here. And so we'll say, all right, so 500 is my circle equals 10 times 5,000. If we can make it look like that, we know, nope, that doesn't work. If you flip those, you're good, but that's what we need to do for each of these. So it's not this one. Let's check this one. 20,212, underline, circle. Okay, so I need to say that this is worth 200, and this is worth 20,000. So let's put this in our equation up here, and we'll say 200 equals 10 times 20,000, because 20,000 is the value of what's circled. Obviously, that makes no sense, so it's not these two. So 3 of the, out of the next 4 are going to work. So let's look at this 26,630. So I've got a circle there, I've got an underline there. So this circle is worth 6,000, and the underline is worth 600. So I could say 6,000 is equal to 10 times 600. Now that finally makes sense. At least one of them makes sense, right? Because when we multiply by 10, we add a 0 to the end of it if it's a whole number. So my 600 becomes 6,000. And so that is going to work, right? So we can take that one, and let's go ahead and mark that one as correct. We need 2 more. So let's look at this one, 9,633, circle, underline. So the circle is worth 30, underline is worth 3, so I can say that 30 equals 10 times 3. Yes, that definitely works when you see it like that. So I got 2 of them correct. So one left. Let's do 41,996. Circle, underline. My underline is worth 90. My circle is worth 900. So I can say 900 is equal to 10 times 90. Same thing as the last one. Yeah, we can take this 10, add a 0 since it's a whole number over there, and we're good. So that looks like it's those 3. Let's just double check this last one to make sure. Because if the last one is right, then we messed up somehow. Because it says only 3 are correct. 848, circle. Oh, notice there's a big gap. There's 2 spaces in between these two, and that's not going to work. When it's 2 spaces, right, that's going to be 100 times. So this is 800 equals 10 times 8. And that's not correct. We either need to make this an 80, or we can make that a 100. Either one of those would have fixed it. So that's incorrect. So those are our 3 answers. Now let's see how we did across the state of Texas. And this is a 2-point problem. So if you got 3 answers, all 3 answers correct, you got both points. We had 55% of our students get all 3 correct, which is pretty good because you have to do quite a bit of thinking on this one. 1 point is you get 2 out of the 3 correct. We had 27% of our students get that, and then 17% didn't get any correct, or if you got 1 out of 3, you still got 0 points. Now how we do this is to find our percent correct. We take our 55, and we take half of the 1 point, and we round it up. So that's going to be 14. So we're looking at about 69%. So that's actually pretty good. Anything above 60, we're feeling pretty good. This is our 4th easiest. So we've started out the test with 2 fairly easy items. This is our tied for our 4th easiest. There's another one with 69%. And so we are going to move on to our next item. For number 3, we are looking at measurement problems. So measurement is going to bring us to standard 4.8C. And as you can see, we're dealing with money. Let's make that a C there. So Kiara has 15 cents in a jar, and then she adds the coins shown to her jar. How much money does she have now? So it seems pretty simple, but I have a feeling we're going to have quite a few students forgetting this right here. Okay? So she already has 15 cents. So I'm just going to write 15 cents. And I'm going to add that. Then she adds these coins. What we need is we need values here. So let's see. It's going to be a little bit dark, so I'll write it underneath, right? So our quarters are worth 25. Each of our dimes are worth 10. And then we've got 2 nickels worth 5. That's the trick here, is making sure we remember the value of coins, but we've been learning the value of coins since kindergarten. So let's skip counting by our largest ones, right? 25, 50, 75. So these three right here, if we want, we can skip count all the way up, or we can just do some partial sums, right? Those three are going to make 75 cents. I've got 8 tens. 10, 20, 30, 40, 50, 60, 70, 80. So let's do all these right here are going to equal 80. So we can just add it like this, line up our decimals. These two right here, obviously, are going to make 5 and 5 make 10. And then we can't forget this. 15 is 0.15. And we just add it up. 5 and 5 make 10. That's 7 and 1 make 8. Another 8 is 16, 17, 18. And we've got $1.80. So here's our answer, A. And if we wanted to, we could have just skip counted right uh, by coins, right? 25, 25, 50, 75, 85, 95, 105, 115, 125, 135, 145, 155. Then by fives, 160, 165, and then 165 plus 15 gets you back up to 180. So either way, our answer here is A. And we actually had a pretty decent time of this. We had 61% of our students get A as the correct answer. So it's not as high as the other ones, but like I said, roughly when we're getting above 60%, we have a decent understanding of that across the state of Texas here. Now, what's interesting about this, we had 18% of our students choose D. And really, how you get some of these is you might confuse the value of things. What I find interesting is that STAAR did not decide to put just this value as a distractor. I would have expected them to have 165 as a distractor. I would I would put quite a bit of belief in the fact that if they had put 165 as one of our distractors, I think that would have got more than some of these others. I think that would have really tripped up some of our kids just because the coin is not showing. The coin is listed right here. But for whatever reason, they didn't give that to us, and so we're just simply adding these up. We had 61% of our students get it correct, so overall, pretty good about coins. This is the tied for the 8th easiest, so we haven't really struck one of our most difficult ones yet. So moving on to number 4, we are looking at two-step multiplication and division problems. This is 4.4H. And so we've got Xenia here. What does Xenia have? She's made hair bows. Put them in boxes to sell, and we're solving them. We're not necessarily representing them, we're solving them. So she made each hair bow with 7 ribbons. She used a total. Okay, so when they give you the word total, that's going to be important. 483 ribbons, and then she filled each box with 3 hair bows. So she filled as many boxes as she could, had no hair bows left over. How many hair bows did she fill? Let's draw a picture here. I'm going to draw a strip diagram to represent this first part. I've got a total. When you see the word total, that means that's going to go on the top of your strip diagram. 483. Each hair bow had 7 ribbons, so we can represent it like this. I'm going to write the number 7, and I'm just going to draw it out like this with a question mark. Because I don't know how many groups of 7 I have. I know how many is in each group. but I don't know how many groups of 7 I have. So I can figure that out. Let's just figure out, right, how many bows we have. Because we're asking about boxes, but I need to know how many bows I have before I know how much they go in boxes, okay? So I've got 483. Let's divide that by 7. So 7 doesn't go into 4, but 7 does go into 48. Almost 7 times. Very close. But it goes in 6 times. 7 would be 49. That's just one too big. So 63. Okay, so we've got 69. So there are 69 hair bows. Now here's the second step, right? So my first step is divide 483 by 7. Now I have a new total. Because I'm going to fill each box with 3 hair bows, I need to make a new strip diagram. Now I've got 69 hair bows, and I need to put boxes of 3 together. And the question is, how many boxes of 3 do I have? So it's another division problem. So 3 goes into 6 twice, and 3 goes into 9 3 times. And like the problem said, no hair bows left over. So there's no remainder. So there we go. My answer here is 23. 23 boxes of hair bows. Now let's see how we did across the state of Texas. The correct answer was D. We only had 35% of our students get that correct. Now, let's check the other ones. We had 29% choose A. How did we get A? Well, if we just took, for whatever reason, 483, and instead of dividing it by 7, we divide it by 3, look what we get. That's 16, and that's 161. So they understood division, the students that chose this one, but they only did one step, and they didn't even divide the correct answers, the correct numbers. 483 should have been divided by 7. That was 69. We see the answer to our first step right here, 69. That's down here. That's 22% of our students got this. Now we had 13% of our students choose B, and you can get that by just multiplying 7 by 3 and just kind of avoiding the 483, which means we're getting awfully close to guessing. I'm pretty confident that some of the students that chose D and got it correct just guessed, because look at the percentages here. When your percentages get near 25%, that means there's not a lot of understanding here, and we're getting an awful lot of guessing. This was the fourth hardest item on the test. Only 35% of our students got it correct. How do we solve this? Pictures, strip diagrams. Because students need to first understand the relationship between the quantities to then understand how do I draw the picture, and that picture is telling me to do what operation. Am I multiplying? Am I dividing? Am I adding? Am I subtracting? The strip diagrams will help our students make those decisions, so they need practice with that. So for number 5, we are relating decimals and fractions. We always will see a few items like this on STAAR tests. Now this one is a little bit tricky, because look what I have here. I've got 29 tenths. There should be one thing that tips us off. This is an improper fraction. So that means it's going to be greater than 1, because the numerator is larger than denominator. So I need each of these to be greater than 1, and they are. So that's good. If there was 1, I could have seen this possibly as a distractor, and we could have been able to get mark that one off because it's less than 1, right? That'd be 29 hundredths. So how do we write 29 tenths? Okay, well, let's think of our place value chart right here, right? Okay, so here's my ones, and then here's my tenths. Watch what I'm going to do. I'm going to show you 29 tenths. So I'm going to do them in sets of 5, okay? So that's my first 10. And here's my next 10. So I've got 20 tenths right now. And I'm going to separate them like this because hopefully you see what we should be able to do. Look at that. I've got 29 tenths. Well, I put them in sets of 10 because we know that when in our number system, right, when we regroup, we can take 10 bundle them together and bring them over. So the 10/10ths is the same as this one whole right here, and I can represent that. Let's represent that with a dot to stay even there. I can take these 10/10ths and I can put another dot. So let's put a second dot there. I can't rebundle those 9/10ths because that's enough there. So I've got 2 1s. It's my decimal. And I've got 9/10ths. Another way to think about this is if you just want to do place value like this and you say 29/10ths, right? So you always need a ones place when you're dealing with decimals, even if it's going to end up being a 0. And you're looking and you say 29/10ths. Well, you can only put one digit in each place. So you can just knock this 2 over and you can write it like this. And you get the same thing. 2.9, 2 and 9/10ths is the same as 29/10ths. So our answer here is B. Now let's see how we did across the state of Texas for that. Correct answer B, we had 64% of our students. So as always, anything above 60 we're feeling good about. We had split evenly amongst the other answers. 13% for A, 12% for C, 10% for D, and overall this is the 7th easiest. So we might have had a few students tripped up if we were to add this 2900s as an option, but students saw the 4 answer choices, knew that other than this one, right, 29 wasn't really going to show up anywhere, but these other 3 were just random guesses because their distribution is pretty equal. So for the most part, we're doing pretty good on that. Let's look at the next item. For number 6, this is a drag and drop, and all we need to do is we need to know our vocabulary. And if we know our vocabulary, we're good. If we don't, we're just going to have to guess on this. So there's no vocabulary definitions in our reference material. Students need to know that these terms, right? So we've got line, ray. 2 other terms that we should learn with these terms are line segment and then point, because that's what these 4 are. So let's talk about the 2 that we know are correct. So this one is a ray. So let's talk about why this is a ray. A ray starts blue with a point and it continues on in a direction forever. So it's got a point and then it continues on forever with an arrow, meaning it looks like it's got a line coming out of it, but it has one endpoint and then infinity in the other direction. Okay? So a line is typically when we'll draw a line, we won't do a true line. A line is actually infinity in both directions. Okay? So a line is infinity in both directions. When we are drawing a line in just regular drawing, a lot of times what we'll do is we'll say that's a line. But this is actually, since it ends, right, we can put points there. That's the third option. That's a line segment. So when we say we're drawing a line, a lot of times we're drawing a line segment. It's only a line if it's got these arrows going on infinity in each direction, and then a point. This one is obviously a point. It's just a single point in space. So that's my point. That's my line. That's my ray. And that's my line segment. And this just requires practice for our students. So those are our 2 answers. It is a 2-point problem. So let's see how we did. You needed both to get both points, and we actually had 54% of our students get both items correct, and we had 28% of our students get one correct. We don't know which one is which, so we don't know if more students got just the ray or just the line. They don't give us that data. So if we take half of our 1, right, that's 14, and add it to the 54, we can say overall 68% of our students got this correct. So that's really good. This is the 5th easiest. So we're starting the test with some pretty easy items, which means the difficult ones come up later. This is 18%. So let's look at our next item. For number 7, we've got Duncan and Priscilla buying 68 apples. They use 46 pies to make for a bake sale, and then they split the remaining apples evenly between them. So we are representing an unknown quantity in this one. We're looking for A, that's our unknown quantity, and that's standard 4.5A. So let's draw a picture of what's going on. This is our total. So when they give us our total, they buy 68 apples. What we're looking for is we're looking for any of these representations, A, B, C, or D, in which 68 is the total. And look, they buy 68 apples, so that's our total that we're doing things with. We're using some, we split the remaining. Look at A and look at B. They don't use 68 as our total, right? So that automatically is just going to eliminate A and B if we can recognize the total. Then we use 46. All right, so I draw, this is going to be a strip diagram here. So I'm just going to draw right here, 46. So they use 46 to make pies for bake sales. So we've done that. And then they split the remaining apples evenly. So here's our remaining apples right there. And they split it evenly. So what does that mean to split evenly? That means to split in two or divide by 2. So that's the tricky part here is we need to be able to divide this by 2. And then each of those sections, right, so I'll divide that in half, is going to be represented by A. So A is how much Duncan and Priscilla split evenly. And so we see our correct answer here is D. All right, and so let's see how we did. We had 20% of our students choose A. We had 13% of our students choose B. We had 22% choose C. And only 44% of our students choose D. So that makes this the 10th hardest item. And honestly, I would have expected, 22% for C is a little bit more than this A right here. But honestly, I would have expected a little bit more for there because you would have at least recognized 68 as the whole. You just forgot to split this in half. I think that's going to be the difficult part here, splitting it in half. But there really is not much difference between A and C. Now, not many students chose B. They split it in half. They just didn't recognize 68 as the whole. And so this was a difficult one. This is where students need lots of practice, taking a story problem like this and line by line, creating a representation, strip diagram to show what they know. So let's look at our next one. And for number 8, we are comparing fractions. Right, so we've got the 6/8 here, and it needs to be less than something. This is going to be standard 4.3D. And it seems pretty straightforward, not much to read. So 68 is less than, or 6/8 is less than, and we need to compare it to each of these. Now, you notice the denominators are different, every single one. So what I'm going to need to do is I'm going to need to take my 6/8 and my 4/5 for each of these, and I'm going to need to generate an equivalent fraction. So the easiest thing here is, I can find the least common denominator. The easiest thing is just to multiply them by each other, right? 8 times 5 is going to be 40. 5 times 8 is going to be 40. There might be a smaller one available at some of these, but that's just kind of our quickest way to do it. Just make sure when you're multiplying, your numerator and denominator are going to be the same here. And so we'll say that 30 over 40 is less than 32 over 40. So right now that automatically looks okay, right? So I'm thinking A looks good. Let's check our other ones here, 6/8 and 7/10. And let's just multiply each by each other. We could multiply to get to 40, but we don't need to find the lowest common denominator. We just need to find a common denominator. All right, so that's going to be 60 over 80, and that's going to be 56. So wrong direction, so it's not B. Let's do the same thing here. And so that's going to be 1/3. Let's multiply it by 3. Let's multiply this by 8. All right, so that's going to get me, what are we going to get? 18/24ths. And that's going to give me 8/24. So 18/24 definitely greater. And then 3/4 and 6/8. We could go to eighths, and if we go to eighths, we'll find that they're going to be equal, but let's just multiply by each other since we've already started that. So that's going to be 32, be our common denominator. And so 8 times 3 is 24, and this is going to be 6 times 4, also 24. So these are equivalent fractions, not what we need. So our answer here is going to be A, 4/5. And let's see, we had 22% of our students choose B. We had 6% choose C, 13% choose D. And our correct answer here, A, not bad, 59%. We'd like to see that above 60, but this is tied for a 10th easiest problem on the test. So what was it about 7/10? Well, if we want to write 6/8 and 7/10, we could say it's less than, or let's say, sorry, less than this way, if we're just comparing the numerators, right? We know it's greater than, because that's if we bring the denominators in. But if we're just comparing the numerators, we could say 6 is less than 7. So that might have tripped some of our kids up. Either way, our answer here is A. And so looking at our next item, number 9, we are looking at area and perimeter. And this is 4.5D. So we've got the perimeter of a square is 40. So let's draw a square. Let's use this connect line feature here. All right, so I'm going to draw 5 units for each just to make a beautiful square. All right, so there's my square. The perimeter is 40. P equals 40. I also know that my perimeter equals 4 times the side, right? Side plus side plus side plus side are 4 times the side. So 4 times what makes 40? So I can say my side is, each of my sides are going to be 10. 10, 20, 30, 40. I've got centimeters as my units. What is the area? Well, my area, right, is going to be side times side, or it's going to be the side squared. And if we need that, we've got this, the perimeter of a square and the area of a square. We've got it right there in our first and third rows in case we need that for our students. So the area is going to be 10 times 10, which equals 100, and that's going to be square centimeters. So our answer here is C. Now let's see how we did across the state of Texas. We had 18% of our students choose A. So they found the side length of 10, 10, 10, 10, but then they ended up just doubling it, 10 times 2 rather than 10 times 10. B, we've got 80 square centimeters. We had 26% of our students choose this one, so 1 out of every 4. So really what happened here is we confused area and perimeter. We took our 40, instead of dividing that by 4, we divided that by 2, get you 20. And then instead of multiplying 20 times 20 to get the area, you just multiply it by 4 to get back to your 80. So it's kind of a weird, not really understanding what area is. It's kind of a perimeter. This is supposed to be area, even though that's not exactly how we find area. It's going to be what number times itself makes 40, not what number times 2 makes 40. Our correct answer here is C. only 42% of our students got this correct. So that's going to be the ninth hardest on the assessment. And then D is 14%. So 14% of our students got this 400. We found the side length, but then we, of 10 times 10 times 10 times 10, but then we multiplied this side length by the perimeter for some strange reason. So this is a fairly difficult problem because they don't give you a visual. You have to derive the side length from the perimeter in order to find the area. So seeing how those two connect can sometimes be a challenge for our students. So for number 10, we are looking at input-output tables, and this is 4.5b. And we need to find a rule, -4, to show the relationship between, here we go, the position of a number and the value of that number. Okay, so they give it to us. So position, and then we've got value. And so what's my rule? My rule is -4. Okay, so you take your position and then you subtract 4. So let's take a look at, I'll just take a look at this first one right here. Just, okay, so if my position was 10, it'd be 10 minus 4 would make 6, because that's what the rule says. The relationship between the position of a number and the value of that number is -4. So position minus 4 makes the value. 11 would make -4, so that would be 7. 12 minus 4 would be 8. You notice that we're off here. They just made the value 4 of each, and they changed. This is supposed to be the rule, and they keep changing the rule to make the value 4. So that's not how that works. So it's not A. We do have a -4 on these. Okay, but take a look at this. If my position is 4, so I'll start this next one right here. Okay, so take away 4 is 0. But then look, they keep the position as 4, but then they do 5 minus 4. Where's that 5 come from? They say the position's 4, but where's that 6 come from? So they're changing the expression, but they're not changing the position. So that's not going to work either. And so let's see what we've got for C here. C kind of does what A does. It's got your position 4, and then -4 is 0. So that's good, just like that one was good. But look at this 8. 8 should be -4, and that should be a 4. And so we've got that one, okay? Um, so we've got the value of 4 for each of these, right? But this one, there we go, that value is 4, but it should be a 0, so that one's off. And then look at this 12. 12 minus 4 should be 8. But they flip these. They want to keep making the value 4, so these two should be flipped. These two should be flipped. These two happen to be fine because they both happen to be 4. They're going to flip these two, so that's not going to work. So let's see if D finally works. Position, and then rule, and then value. All right, so I've got 10 minus 4 should be 6. Yes. And what they're doing is they're just rewriting the position as the first number in the expression, and that's fine. 11 minus 4 should be 7. Yes. 12 minus 4 should be 8. Yes, and then we're going to end with 13 minus 4 should be 9. Finally, we found one here. So our answer is D. Now, let's see how we did across the state of Texas. We had 17% of our students choose A. We had 16% of our students choose B. 20% of our students choose C, which means when these are all very close, that means students that are guessing an incorrect answer, they probably just didn't know what to do, because there's not one of these that really showed up as a distractor that was trying to trick kids. When all your incorrect answer choices are evenly distributed by that, you can just kind of infer that there's a lot of guessing going on. We had 47% of our students, less than half, get this correct. So this is the 13th most difficult item. And so this just takes a lot of practice to really set up that rule like it says between the position and the value. For number 11, we've got a drag and drop here. Expanded notation is what we are looking at, and this is item for 4.2b, and we've got a basic number, and we need to write it in expanded notation. So let's do this. I'm going to write a place value chart here. I got my decimal right there. What I want to do is I want to write the value. It's the tenths place, it's the ones place, the tens place, the hundreds place, thousands place. If I write a place value chart instead of using words to show the value, I just use the value of each place value, then expanded notation becomes very easy because it's going to be 4 times what's that place, thousands place, plus I don't have a hundreds place, I don't have a tens place. I've got 2 times a ones place, and then I've got 7 times tenths. That's it. That's all we got to do. So let's bring that down. 4 times 1,000, 2 times 1, and then 7 times tenth. Let's make sure we got ours correct. Yeah, that's all we need to do. This is a 2-point problem. So let's see how we did. In order to get both points, you need to get all 3 items correct. So I'll write that over here for us. So to get all 3 correct, we had 68% of our students get this. That's fantastic. You had to get 2 correct to get 1 point. And we had 10% of our students. So remember, we take half of this, right? So that's 5%, and the 68, because that's half credit, that's 73% correct if we want to look at it like that. That's good. Fantastic. 0 or 1 correct. So even getting 1 correct gives you 0 points. We did have 22% of our students still not sure. So that's still quite a bit, but overall that 73% makes this the 3rd easiest item on the test. Pretty good. They didn't have any super tricky ones. Sometimes the hundredths can throw kids off. There are some zeros in there, but for the most part, we did okay. So we should be pretty pleased with that percentage, that 73%. So next, we are multiplying by 10 or 100. This is a concept that if students understand it, they can usually blow through this pretty quickly. But sometimes it is difficult. So we've got 476,500. We need to multiply that by 100. So let's figure out what our pattern is, okay? So if we multiply 1 times 100, we get 100. 2 sets of 100 get you 200. 3 sets of 100 get you 300. And check our pattern. What we're doing is when we multiply by 100, we just take the other factor that we're multiplying, and we're just writing 2 zeros because there's 2 zeros in 100. 4 times 100 is going to be this 4 with these 2 zeros, right? And then 10 times 100, 10 hundreds, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000, or 1000. It's going to follow that same pattern. You take your 10, the number you're multiplying by, and you add 2 zeros. So when we're multiplying by 100, we are literally adding 2 zeros. 20 times 100. We take our 20. We skip count by 20 up to 100 times. We take 100 sets of 20, right? Or 20 sets of 100. It's going to get us 2,000. So we can do that same thing here. And this is just the pattern that students need to recognize. There's a whole lot of zeros here. This is a little bit harder than it seems to be. So here's that pattern. 476,500 times 100 equals this whole thing. I'm going to write it again down here. And I add 2 zeros. That's it. I just added 2 zeros. But my commas are going to be in different spots now. So now it's 4 millions. Let's see, I put that comma right there. How about that? 47,650,000. So our answer here is A. This was a little bit more difficult than we would expect. We only had 31% get this correct. We actually had more students choose B. Now, you see this right here? This keeps the 476,500. That keeps that intact. But look what it adds. It adds 3 zeros. There's only 2 zeros. This would work if this was times 1,000. If we can multiply by that 1,000, we would get 3 zeros and we would keep all the commas. But this looks exactly the same. It keeps the commas. It just adds one too many zeros. Now we're taking zeros away in both C and D. We didn't have nearly as many students choose that. 9%, 16%. But take a look at this. Rather than just following the pattern, they found something that looks similar, but they didn't count how many additional zeros we had. This was our third hardest item, one of the few rare ones in which more students chose an incorrect answer than chose the correct answer. All right, so looking at our next one, number 13, we are measuring angles. This is always a tricky one for kids. This is 4.7c. Protractors and angles are taught for the first time in 4th grade. So it's a brand new concept. So we need to find 95. Now, let's use our just basic knowledge of angles. Okay, so I'm going to use connect line feature. And I'm going to draw this. We should know that this is a 90-degree angle or a right angle. Perpendicular, straight up, straight across. So when I've got 95 degrees, it's going to be very, very close to this. 95 degrees is going to be just a little bit bigger, so I might kind of draw it like this if I could. Okay, that's going to be my 95, which means even before I look, A looks close, B does not look close, C looks close, so it looks too small, and D, I guess if you rotate it, looks close. I've already eliminated one answer, B, because it's not even close to a 90-degree angle. All right? So how do we actually measure? Well, we have to subtract, right? So I've got 0 if I'm going to use the outside and 90. 90 is the same for inside and outside, so I have to subtract the two measures. 90 minus 0 equals 90. I could also subtract the inside. That's 180 minus 90, also equal 90. This is a 90-degree right angle, so that's close, but not quite. Now, let's check this one. If I'm using the outside measure here, this is between 90 and 100. This is 95 and 180. So I have to do 180 minus 95, right? So that's going to equal 85. If I use the inside, I've got 0, and then I've got that 85. So this is 85 minus 0. You just have to measure outside and outside or inside and inside. Easiest one obviously is the inside since it's opening to the right. Not what we need. So let's check our D. Let's measure since it's opening to the left, let's measure the inside. We've got our 10 and we've got our 105. So you have to just know what becomes between 100 and 110. So 105 minus 10 equals that 95. Let's measure the inside just to see if it stays the same. All right, so I've got this 170 minus between 80 and 70 is 75. That also equals 95. So that is our answer. It is going to be D. Now let's see how we do here. We only had 46% of our students choose this one. Less than half. For A, not many, 10%. For B, 6%. Even though it's on the 95 on either side, most students were they were able to capture that as incorrect. C. C is the one that got that. Look at this. 38%. What was it about that? Well, it's close. We didn't immediately eliminate it. But if I look on the outside, look, it's right there between 90 and 100. So this ray, if you're using the outside measure, measures at 95. The problem is, since you're using the outside measure, you need to subtract that from 180, not the 0. So we just need additional practice with our students to make sure that we're subtracting two numbers on a protractor, not just looking to see where one ray is pointing. For number 14, we are looking at adding and subtracting fractions. This is 4.3e, and it's actually a pretty simple problem when you're looking at the problem itself, but we have the equation editor that we need to use, right? So each type of shirt that Don owns is shown. We got some solid, some stripes, and dotted. So we need a fraction of the shirts that are either solid or striped. Okay, so we've got two choices here. Really, if we wanted to, we don't even need to add fractions, right? We've got solid and striped together. So I've got 1, 2, 3, 4, 5, 6, 7, 8 out of how many, right? 8 solid or striped. I've just got one dotted that I didn't include, so it's 8/9. Now, another way to view this would be just to view this as ninths, right? And then we can add each of these. I've got 1, 2, 3, 4, 5/9 for solid. I've got 1, 2, 3/9 for striped, 5/9 and 3/9. It's still going to give me that same answer of 8/9. So really, you could do that either way. So we need 8/9. The challenge here is going to be using this equation editor, because what we need is you need to actually push the fraction button first. That's going to get you your numerator. Then you have to click on the gray box to get the cursor down into the denominator. And there we go. Our answer is 8/9. Now, let's see how we did. Across the state of Texas, this is a 1-point problem because it's either correct or incorrect. And we only had 39% of our students get it correct. And honestly, I do think that part of that might be how unintuitive this equation editor is, because let me go back to this and let me just erase everything. If you hit the 8 first and then hit this, it's going to turn it into a mixed number. And even if you try to do that, it's still looking for a numerator. You have to hit the fraction button first in order to get the numerator going. So that's just the unintuitive part, because students are probably going to want to hit the 8 and then the fraction button. But as I said, this was 39% correct. So this is our 6th hardest item. I'm not sure whether it's the actual adding of fractions. We don't know what the incorrect answer choices are, or if it's simply because using the fraction button isn't the easiest in the world. So let's get an 8/9 in there so it lets us move on. There we go. Now we can move on. For number 15, we are solving data problems. This is 4.9b, and we have a stem and leaf plot. Always, first thing we need to see is our key. Take a look at this. 7 line 1 equals 7.1. It's a little bit confusing because it's got a period there. I don't know if we necessarily need that period. It's not really a sentence. Looks like 7.1 dot. But either way, these are decimals, right? So that means these are the ones place, and the leaf is in the tenths place. Okay, so we need the difference between the highest and the lowest scores. All right, so my lowest scores, right, I've got two scores here. I've got 6.2, 6.7, right? So my 6 and 2/10 is my lowest. Then I'm looking at my bottom row. I've got 9, 9 and 2/10, 9 and 2/10, 9 and 6/10, right? I'm just using that 9 and a decimal, and I'm getting each of these, and obviously my highest is here. So the difference means subtraction between highest and lowest. 9.6 minus 6.2 is 3 and 4/10. 3.4. So my answer here is B. Now, how did we do across the state? Well, we had 10% of our students choose A. That's just subtracting the greatest and the least digits in the leaf. So if you wanted to subtract 8 minus 0, you would get 8. Obviously, our correct answer there is B. We had 61%, so it's a hair above 60%, not horrible. We had 14% choose C, and that's just adding the highest and lowest, right? If you just take it to this, 9.6 plus 6.2, you get 8, and you get a 15. So they picked the right numbers. They just thought difference meant to add. And then we had 34, and that's, notice how 34 is very similar. Let me screw this down a little bit. To 3.4, this was 15% of our students. They just didn't read the key. They thought it was 96 and 62. So they did everything right, except they didn't read the key to realize that we should have a decimal there. So 61% of our students got this correct. That's pretty good. This is our 8th easiest, tied. And so for the most part, we do pretty good with data problems, stem and leaf problems. All right, so let's look at number 16. The amount of money Amar has left, and it's another equation editor down there. Okay, so we've got money left after buying a snack was shown. So let's see how much money we've got left first to figure out what's going on. What is this collection of bills and coins? So let's do my bills. I've got $10, $20, $30, $40, and then a 5. So I've got $45. And then I've got coins, right? 3/4. 25, 25, 25. So 25, 50, 75, 85, 95, because those are dimes. So I got 45.95. He uses $50 to buy a snack. How much money does Amar have spend on the snack in dollars and cents? So this is the change. So this is where it gets tricky. And there's really, there's two ways to do this, right? First off, you can say, all right, this is a subtraction problem. Now, we've got to line up our numbers correctly. $50, 50.00. But now, look at all this regrouping I'm going to need to do, right? It'll get us the correct answer. But I need to borrow from the 5, right? That's $10. I'm going to take a $10. I'm going to leave 4 $10. Break the $10 into 10 ones. I'm going to take one of my ones, leave 9, and bring it up into 10 tenths or 10 dimes. Got to take a dime, leave 9 dimes, break it up into 10 pennies. Now, right, I can subtract, but I had to do a whole bunch of regrouping. So $4.05. Now here's an easier way to do this, right? 45.95, right? If I add 5 cents, look what I get. I get a really simple, I should know number sense wise, right? That's just 5 cents away from 46 bucks. So I'm going to add 5 cents to that, and I want to add 5 cents to my 50. And watch what happens. It's the same difference. 50.05. Now subtract those two. Tell me which one's easier. 50.05 minus 46. Look at that. No regrouping. Sometimes you can just add something to both. There's a little regrouping there, but I think we get that. Add a little something to both to make it a much easier problem. So 405 is the answer either way. Now we've got to use our calculator here. So it's a dollars is already included there, so 4.05. All right, so that's our answer. It's another 1-point problem. How did we do across the state of Texas? This is the hardest question. We only had 20% of our students get it correct. 1 out of every 5 students were able to calculate this. So we had to add the collection of coins, then we had to subtract from 50. So we only had 20%. So first hardest, first most difficult out of the entire test. So I don't know like I said, whether it was the collection of coins and subtracting from 50, or simply, inputting this into the calculator, because some students, right, might have mistakenly, put a 4.5, right, not put that 0 there. So that's a very difficult problem for some of our students to look at, and honestly, there's a few steps that might have tripped them up. So for number 17, we are looking at point F here, and it is asking us to solve or to find equivalent fractions, and that is going to be 4.3c. This point F represents two fractions. Well, first off, we should say 1, 2, there's 3 spaces, so I'm going to write this in thirds. 0 thirds, 1 thirds, 2 thirds, 3 thirds. Okay, so I've got 2 thirds, so I could do this and I can do this. I've already eliminated those two without even drawing fractions. How could 2 thirds and 1 third be the same thing? 2 thirds and 1 thirds, they have the same denominator, so I can compare them. 2 thirds is greater than 1 third, so they can't be equal. I need 2 thirds to be equal to something, which means the only one left is this 2 thirds and 4/6. So you can use process of elimination. Okay, now we don't have to use process of elimination because one trick is to always take each of your fractions, cut them in half. So I'm going to draw blue lines here to cut each of these in half. And I'm going to draw a blue line on the tick mark. Look what I've got now. I've got 1, 2, 3, 4, 5, 6. My third's turned into sixth. So I'll do 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and 6, 6. So there's my 4, 6, and 2 thirds. So my answer here is B. Now here's the interesting thing. This is 4.3c. This is the first time that this particular standard has ever been tested on STAAR. So this might not necessarily be one that teachers pay a lot of attention to because it's never been tested in the past, but it is a supporting standard. And we only had 41% of our students get this correct. 41%. Now, this is very close to a third grade standard. And so this is probably one in which teachers think that they have mastered this from third grade, but it definitely requires a little bit of work in our fourth grade. And so let's look to see how students did in the other options here. So for A, right, we had 22%. So we're going to find kind of we're kind of stuck here between A, 22%, and B was 41, but look at C, 23%. So these are our most chosen incorrect items. So at least this one had 2 thirds, right? And then D had 14%. So we're really kind of all over the place there. And when you have A and C, both kind of there, then it lets you know that you're kind of guessing because really this is a standard that lines straight up with 3.3F. Like I said, this is a third grade standard, and this is a third grade readiness standard. So this is a readiness standard. So you would think that our students would necessarily have this, but they probably still have some difficulties with this in fourth grade. Obviously, with this being 41%, this is the seventh most difficult, seventh hardest item on the test, tied. So even though this is a readiness standard in the third grade, doesn't mean that we can just skip right over this in the fourth grade. For number 18, we are drawing angles. This is 4.7D. And Clayton is using a protractor here to construct an 85-degree angle. We already have one ray down here, PQ. Okay, so I know that my other ray needs to start at P and then hit one of these other letters that we have here. 85 degrees. So I want my horizontal ray here, PQ, to start at 0. So 0 is the inside number, so we're going to use our inside numbers to count. So 10, 20, 30, 40, 50, 60, 70, 80. So 85 is right after that. That's going to be right through here. And look, I'm hitting at point S. Okay, so that second ray is going to give me an 85-degree angle. It's almost 90. It almost looks like it's a right angle, but it's not quite vertical, not quite up and down. So how did we measure this? Well, let's look at our inline choice at the bottom. To complete 85-degree angle, Clayton should draw another ray that starts at point, where do I start? I start at point P and passes through point, where does it pass through? S. All right, so let's get point P. Let's make sure we got this correct. Point P and then point S. All right, did we get that correct? Point P and point S. Yes, we got that. So this is a 2-point problem, and we had only 25% of our students were able to get both of these. That's not a lot. Now we had 32% get 1 point, right? So if we take half of this, 16 and 25, you're going to get 41%. Still not that good, because we had 43% of our students coming up on half get 0 points. So this was definitely difficult, and most likely because our students are used to measuring angles, not necessarily drawing angles, and naming the points that they pass through. So that could be a new unique feature for our students, is naming starting at point P, passing through point S. This is a new way that we can help our students as we're learning with protractors. And so this was our 7th most difficult. It was tied, but 7th hardest, 41%. So definitely one that we want to look at again with our students. All right, so moving on. Number 19, Colleen buys a roll of craft paper and some glue. She saves 75 cents for a coupon. What's the total cost? So we are adding and subtracting whole numbers and decimals. This is 4.4a. So let's just think what she's doing. She's buying craft of roll paper, a roll of craft paper here. So let's see, I'm going to say right here, so it's going to be $7.99. That's my craft paper, CP. And then she's also buying some glue for $3.69. Now the question is, what am I doing with this 75 cents? Am I adding it on or am I subtracting it, right? So when you save money, that means you buy less, you spend less, and a coupon also means you save money. So really what I need here is I'm going to draw like a little hash mark right there, and that's going to be my 75 cents. That's my coupon. So really what I need to do is I need to add my $7.99, my $3.69. Okay, so let's see what that gets me. That's 18, that's 16, and that's going to be 11.68. Okay, and then I'm going to subtract my 75 cents. I am going to need to regroup here at least once. So that's going to be $10.93. So my answer here is B. Now, there was quite a few steps. So let's see how we did across the state of Texas. We had 55% of our students get this correct. So that's actually not horrible. Not as bad as I thought it would be. We had 22% choose A. And you can probably guess how we got A. We just added the 3. We just added $7.99, $3.69, and that 75. So really the question here is, how do we help our students understand that when you save, when you use a coupon, both of those mean subtract, right? That's a real world situation. We had 14% of our students choose C and 9% of our students choose D. These are just when you have an error with regrouping, either with the addition or the subtraction, you just make an error, you just end up with some of these. So this was our little bit more on the easiest side. This is right in the middle, if you think about it. 32 item test, 15th easiest, so it's almost right in the middle, and it's tied. So 55%, not horrible. We just need to make sure our students have enough understanding and frame of reference to know that when you save money with a coupon, you are actually subtracting. All right, so we are moving on. Number 20, we are comparing and ordering numbers. This is 4.2c, and we just need to find the correct comparison. Now, that's a lot of numbers right there, and they're all shown horizontally. I want to show them vertically. So what I want to do here is I want to use my colors here. I want to draw between the periods here. I want to do like this, right? And then I'll just do some lines like this. I want to separate, rather than commas, I want to separate the ones period, the thousands period, the millions period, okay? So that's going to be my ones, tens, hundreds, my ones, tens, hundreds, ones, tens, hundreds, and this is my ones period or my no-name period. And then I've got my thousands, so 1,000, 10,000, 100,000, and my millions, 1 million, 10 million, 100 million. Okay, so let's just put our numbers in here. Obviously, we need to make sure we draw everything correctly. All go to 9 digits, so we can just go from left to right. So 3, 5, 4, 8, 3, 5, 2, 5, 6. Next, we've got 3, 4, 5, 8, 9, 7, 187. And then I've got 3, oops, let's make that a 3, 5, 4, 8, 5, 5, 6, 7, 5. Now look at the direction I'm going here. It's something is less than something is less than something. So let's put this in order from least to greatest. So we're going to look at the largest digit first, right? So that looks the same. Here's my first difference. Look at that. I've got a 4 is going to be less than 5 and 5. So I can automatically tell you that this is my first number. 3, 4, 5, 8, 9, 7, 187 is less than. And so that doesn't have the correct first number, and that doesn't have the correct first number. Okay? So then we've just got two other choices here. So moving to the next one, 5 and 5 are the same. And really, I'm going to cross this one out. It's already the smallest, so I'm looking at the next one. 4 and 4 are the same. 8 and 8 are the same. Here's the difference. That 3 is less than 5, which means my next number is going to be the 3, 5, 4, 8, 3, 5, 2, 5, 6. And my last number is going to be that final one, 3, 5, 4, 8, 5, 5, 6, 7, 5. So I need this 3, 5, 4, 8, 3, 5 second, and that's it right there. 3, 5, 4, 8, 3, 5 is second, and then the 8, 5, 5 is third. Okay, so my answer there is going to be C. Now, this is a difficult one just because, I mean, they go up to the 100,000s. That's just a lot. That's a lot of numbers. We had only 46% of our students get this correct. And then we had 27% choose A, right? We only had 18%. Look at this. We only had 18% choose B and 9% choose D, but at least B had the correct first number, right? So honestly, here's the funny thing. This is in the correct order, but from greatest to least. So students might have done all the work and they just confused the symbols and they thought the largest number had to go first. So that might be why we had so many students doing that. So we have to not only help students figure out how to order these things, but then make sure they can understand the difference between the greater than symbol and the less than symbol. And this was kind of right in the middle. This is the 15th most difficult, and it was tied for the 15th most difficult. For number 21, we are calculating profit. This is standard 4.10b. And so we've got this story situation here with Addison buying a chair for $15. She buys paint for $9 and then repaints it. And she sells the chair for $42 what is her profit? Well, we need to know what this means. So profit, right, is the money made, but it's after accounting for expenses. So let's think about what happened here. So she buys a chair for $15, okay? So we've got $15. This is money that she's spending. $15 to buy the chair, $9 to repaint the chair, to buy the paint. She doesn't pay anyone to repaint the chair. She does that herself, so that doesn't cost her any money, just costs her time. So far she has spent $24. Okay? Now she earns $42 because that's the price that she gets for the chair. So she doesn't get $42 as a profit because she's already spent $24 in order to get that 42. So we need to subtract that 24 from that 42. We could think of it as a strip diagram if we really want to. That's our total, right? So this is our going to be our 24, and this is our profit, okay? And so we regroup here, we get $18. So even though she got a price of $42 because she already spent 24, she only gets $18 worth of profit. Still good, but it's not the full 42. So how did we do? Well, we had 15% of our students choose A, which as you can see, this is just the amount of money spent. We had only 10% of our students choose B, which is good because that's the full sale price. For our correct answer of C, we had 55% of our students. Okay, so that's not horrible, but our most incorrect answer was this D, 21%. And this is where we really don't understand because this is a 15, 9, and 42. You add them all up, and that's what that gets you, that 66. So 1 out of every 5 students didn't understand this story situation, and they just added everything. So that means we need to provide some extra opportunities for our students to just interact with these profit situations about spending money and then subtracting that from how much we earned. And so this is right in the middle. This is the 15th easiest, tied for 15th easiest. And so not super easy, not super hard. All right, number 22, we are comparing fractions. This is 4.3D. And so let's take a look at what we have here. This is kind of tricky because we've got red, green, black, purple, 4 different fractions. And we know when we compare fractions, we need the same denominator, right? But look, only these two can be compared without doing any work, green and purple. And I could do that one right here, right? But other than that, I'm going to have to change some things. And they're all improper. Hopefully we notice they're improper. That means that the numerator is larger than the denominator. So I need to find a common denominator, but honestly, I don't feel like changing these. I know that I can change the 2 and the 6 into 12 because 2 and 6 are factors of 12. So let's do that. Let's just change everything into 12. So I'm going to write 17 halves times something. It's going to give me an equivalent fraction with the denominator of 12. 2 times 6. So that's going to be 17 times 6. I have to do a little math over here on the side. That's 102. 102 twelfths. Okay, this green is 126 twelfths. And this 60, I can just double that, right? Look at that. Double that, and that's going to be a pretty easy 120 over 12, and then I've got 90 over 12. Now that I've got everything over 12, I still have to do a little bit of work, because what I want to do is I want to replace each of these statements with an inequality. So the width of the purple is 90 twelfths, is less than, so goes this way, because it can be turned into an L that's rotated a little bit, is less than the width of the red, 102 12. Yeah, 90 is less than 102. So that looks good. Let's verify that B, C, and D are incorrect. The width of the black, that's going to be 120 over 12, is less than purple 90. No, it's greater than. It's going to be like that. So the answer is incorrect. The width of the red is equal to the width of the black. I don't think any of these are equal. So 102 twelfths is equal to black 120 twelfths. No. Incorrect. And then the width of the green is equal to purple. Oh, those were both already twelfths. 126 twelfths is not equal to 90 twelfths. All right, so A is our correct answer. Now, that's a lot of work for students to do here. Let's see how we did. We only had 37% of our students get this correct. Only 37%. More students actually chose B. 40% of our students chose B. They saw all of these and they said, oof, I don't feel like doing that. How do we get B? Well, the width of the black is less than the width of the purple. Well, let's just take the numerators only. 60 is less than 90. So that is correct, but it doesn't work because the denominators aren't the same. So you can get B if you're only comparing the numerators, right? And then C is just kind of weird. We only had 13% do it, right? The width of the red is equal to the width of the black. And it's one of these to where if you round your 17 to 20, and then you multiply that by 3, you would get up to 60, but it's a lot of work. And then 10% chose D. And that's what's equal are the numerators, right? Are the denominators. 12 and 12 are equal. But obviously the numerators are not, so we can't do that. So this is the fifth hardest. And we need to provide our students lots of opportunities to first understand that you can't compare these without the same denominator, and then just practice, practice, practice generating equivalent fractions without any type of visual. That is a new standard for fourth grade and can be quite difficult without a lot of practice. So for number 23, we are representing an unknown quantity. This is 4.5a. And we've got some drop downs here, and they're just the four operations. That's all we need. Not sure why the four operations aren't in the same order for both, but that's okay. So let's see what our problem is. Caroline and David each own a flower shop. Caroline has 156 red, 142 yellow in her shop. So I'm going to write Caroline. I'm just going to draw this bar right here. Represent what I have. I know I've got 156 red, 142 yellow. Okay, so she has 39 more tulips in her shop than David has in his shop. So David has almost the same amount. I'm going to draw equal bars, but what I'm going to do is I'm going to cut a little bit off, and I'm going to say this is 39, and this is David's tulips. So David's tulips are 39 short of whatever Caroline had. Well, what does Caroline have? Let's add the 156 and the 142, and that's going to be, let's see, 8. Okay, so our whole here is 298. And then David's got 39 less than that. So I need to find an equation that can be used to find the number of tulips that David has. Well, I could take my 298 and I could subtract my 39. And that's going to get me 259. So David's got 259. They're representing that with the letter T here as an unknown quantity. So T, because my 259 plus my 39 will get me back up to my 298, which is how much Caroline has. How did I solve that? Well, what did we do with our 156? and our 42. Well, that's how much Caroline had. So we took those two and we added them. And then we know that that's 39 more than what David has, so we had to subtract that. So that's going to be our correct answer there, is we add the 156 and then 142 and then subtract the 39. That's going to be to compare. Now, how did we do on this problem? Well, this is a 2-point problem, right? So full credit means you get both of them correct. And we had 37% of our students get both correct, and 37% get at least one of those correct, right? So if you take that, that's going to be 37 and 19. So that's going to be roughly 58% correct. So not horrible, but it's also, not the best in the world. This is tied for the 13th easiest. And so this is one in which our students just need practice taking a situation like this and drawing a representation as they go, right? If they start seeing these quantities and they can start drawing strip diagrams to represent whether it's a part whole, whether they're comparing two numbers, that is what's going to help them easily create the equation. But if you're going straight from just the word problem to the equation, that's what's going to be difficult for some of these students. They need that representation that they draw to kind of store their thinking as an intermediate step. Number 24, we are dealing with area and perimeter. So this is 4.5D. We've got this floor plan here, and this is a composite shape. So composite shape is actually a third grade standard, but we can bring it up to fourth grade if we want to. And we're looking for the area. So there's a few different ways that we can do this, right? So what we need to do is we need to cut this into two different rectangles. So let's just do it right here. And I'm going to show you that you can do it. You could do it in multiple ways if you want to, right? So if I do it right here, now I'm going to have a 10 by 12, so that's going to be 120. And this is what? Feet squared, square feet. And then I've got a 24 by 8. We can multiply that. That's 32. That's 16, 19, 192. 192 feet squared. So if I add 192 and 120, right, I'm going to get 312 square feet. Now, that's not the only way to do it. You could draw it like this, right? So now I've got a 20 by 10, so that's 200. Then I've got an 18 by 4, or 14 by 8, excuse me, and that's going to be 112. And 112, I'm not sure why I wrote percent there, 112 square feet and 200 square feet still gets us 312. If you really wanted to, we don't have to calculate it, but you can even make 3. You can do a little one there and a little one there, right? This would be an 8 by 10. This would be a 12 by 10. And then this would be, you'd have to do a little bit of calculation on this one still. This would be the 14 by 8. Add it all up, either way you do it, you still get your 312. So let's see how we did across the state. So we had 17% of our students get A, and this is just multiplying. If this were a full rectangle, right, that's the 24 times the 10, but that assumes that this is also part of the area and that part needs to be excluded. All right, so for B, we've got 480, right? So we've got 25% doing this. And this is the 24 times the 20. So they knew they had to multiply the 24 by something. So this is 24 by 10. This 24 by 20, that's the one that would include this blue part right here because they just took those two numbers. 88. We had 36% of our students choose this. This is the most chosen incorrect answer. Now, 88 is a far cry from 480 or 240, but you know what this is? It's perimeter. Because a lot of times when you see a problem like this, it's a perimeter problem. You just add up all the sides. So we need to help our students find the difference here between area and perimeter. Just know the difference between the two. And then 312 square feet is the correct answer. Look at this, 22%, less than a quarter got this correct. And so that's a little bit concerning. This is the second hardest problem on the test. I don't necessarily think the math is that hard. It's recognizing. This is about recognizing what type of problem this is and knowing that I need to create, non-overlapping adjacent squares, rectangles, in order to find an area of a composite figure and not just simply adding up all the sides because you see a whole lot of numbers. Just because you see a lot of numbers doesn't mean it's perimeter, and that's something we need to help our students understand. So next, 25, we are modeling division. This is 4.4e. And let me see, we've got an array shown here. And we need to find an equation that can be used to find the number of unit squares in each row. Okay, so how many do I have in each row of the array? So we need to know the difference between columns and rows. So rows are these that goes side to side and up and down like this. That's a column. So the fact that it asks for the row is going to be very important. So what do we have here? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I've got 12 in each row. So if I want to, right, I can go ahead and mark that in our answer key, right? Before I even figure out the rest of it, I can say there are 12 in each row because that's going to answer the question, how much are in each row? I could also be thinking about, well, how much do I need to, you know, how much do I need to have all together? What's my first number going to be, right? My dividend, and I need to figure out how many rows there are. So I've got, let's do that in black. Let's do that in blue. Okay, I've got 1, 2, 3, 4, 5, 6, 7. Now I've got 7 rows. So what that means is I could take that 7 because I can put that right there. Now ultimately I need to know how many do I have altogether. That's 12 times 7, right? That's going to be my 84. And if I don't know that fact, I can still, multiply 12 times 7 to get my 84. Some fourth graders know that fact and some fourth graders don't. Third grade, they only need to go up to 10 times 10, though a lot of teachers still go up to the 12 by 12, which is what we used to have to do in the old standard. So this is the problem. It's a 2-point problem. 84 divided by 7 gets us 12, right? And 12 is the number of unit squares in each row because there are 12 across. Now, it is incorrect if you were to flip this. Okay, so if you were to flip this, and if you were to say 84 divided by 12 equals 7, that is a correct fact, but that is incorrect because equals 7, right, our quotient is supposed to answer this question. There are not 7 in each row, there's 7 in each column. So we need to make sure we get our numbers correct there. And so how did we do across the state of Texas? Well, it's a 2-point problem. And so if you got all 3 items correct, okay, so if you got all 3 items correct, you're going to get 2 points. And we had 41% of our students get that. If you get 2 out of the 3 correct, you're going to get 1 point. We only had 8% of our students. All right, so you put that together, you're about 45%. So you either knew it or you didn't, because there's not many students that were able to get just, 2 out of the 3 correct. But we had 51% of our students here get either 1 correct or 0 correct. So less than half were able to get any points, right, on this. And so this is the 11th hardest item on the test. This was a little bit difficult And a lot of times when we're modeling division, we might not necessarily be so specific on arrays that we're talking about rows and columns. That's an opportunity for us as teachers to help our students use that language. For number 26, we are looking at expanded notation. This is standard 4.2b, and we've got Nancy here. Nancy's mom, actually. What is Nancy's mom doing? She is driving this one, 106 and 35 hundredths miles. So we need to write that in expanded notation. So first, let's notice what this is. Okay, and is going to be my decimal point. So I'm going to transfer this into standard form first, then we'll go into expanded notation. So and is my decimal point. So 106. We don't say 106 because that and means decimal. So 106, we need to be able to write 106. There's my 106. Now, 35 hundredths, that last number tells me how far I'm going. Tenths, hundredths, so I'm going to do 35. All right, so that's what it looks like in standard form, 106.35. Now, let's write the value of each of these, right? So this is my tenths place. I'm going to label it 0.1. Hundredths place, 0.01. The 6 is in the ones place, tens place, hundreds place. If we can label our place value chart like this, then expanded notation is pretty easy because I take each digit and I multiply it by the value of its place value. So 1 times 100. Right? Plus, I don't need this. There's a 0 there, so we're going to skip it. 6 times its place value, 1. Plus 3 times its place value, 1/10. And then 5 times its place value, 1/100th, or 0.01. And we have all that, and we see that our answer here is going to be B. Now let's see how we did across the state here. So we had 7% of our students choose A. We had 10% of our students choose C. We had 7% of our students choose D. And you see here, C was the most incorrect answer. The rest of these are just wrong all over the place. But this person at least got the whole numbers right. And they read 35 hundredths as 35 hundreds. So difference there. And as you can see here, this person just pretends like the place value doesn't exist, right? This is, if I were to remove the decimal, that's what D is. The digits in the correct order, just without that decimal. And then this looks really good right here on A. You notice that this just needs to be 1 times 100. Everything else looks good. We had 76% of our students. Way to go, Texas. 76% of our students got that right. This is tied for our second easiest. So we did really good on that. So kudos to all of the teachers that are helping our students with expanded notation. For number 27, we are looking at long division. This is standard 4.4F. And we've got this very simple problem here. Calvin is driving 1,924 miles over 4 days. He drives the same number of miles each day. So this is our clue here that we're dealing with equal groups. And when we are dealing with equal groups, we are either going to be multiplying or dividing. If we simply have those two sentences and then the question, how many miles does he drive each day? So the trick here is, what is the relationship between these two quantities? Well, if he drives this many miles, this is our total. So I need to draw a strip diagram here, and I'm going to put 1,924 as my total. And he's going to drive it in 4 equal days. So I will simply cut it in like that. And my question is, how much is each day? Now, if we can get our kids this far, then they will most likely say, oh, this is going to be a division relationship. I need to divide 1,924 by 4. But this is the tricky part, is to understand that we are going to be dividing. So 4 goes into 19, almost 5 times, but just 4 times. We're going to bring down one number at a time. 4 goes into 32 8 times, nothing left over. And then 4 goes into 4 one time. And we get our remainder of 0. So it's, you see how close we are with these two, right? 480, 481. Our answer is going to be C. And you might think it's very easy, but 33% of our students, so 1/3 of our students, chooses A instead of C. How do we get that? Well, that's going to be 1,924 times 4. So that would obviously have a much larger total. So here's the big question for our students is, do we recognize this as our total? Right? If this is going to be our total, then coming up with a larger total, how do you drive 1,924 miles and you end up driving 7,696 miles each day? Right? Once you put it in that context, that doesn't make sense. But we just need to give our students extra opportunities to practice recognizing what's the total and what's the part. Because if we can recognize the part and the whole, that makes it a little bit easier. We only had 10% of our students choose B, so that's kind of background noise. 8% of our students choose D, that's 1920. That's where we just subtract the two quantities. We had a little bit less than half, 49% of our students get this correct. So I definitely would have liked to see that a little bit higher. This is actually slightly harder than it is easy. It's the 14th hardest, pretty close to the middle of the pack. But less than 50% of our students were able to understand this relationship between the part and the whole, and that's kind of the trick with this particular problem, is recognizing that relationship, and then from that relationship, understanding the operation that needs to happen. For number 28, we are classifying 2D shapes. This is standard 4.6D, and we've got 5 different shapes here. We need to select 2 figures. This is a 2-point problem that have at least one pair of perpendicular sides. Now, this is not defined for us. We need to know that perpendicular sides are when 2 sides or 2 lines come together and they form right angles, 90-degree angles, one vertical, one horizontal. Now, you can have it rotated a little bit, but typically we'll see it in vertical and horizontal, right? So we have perpendicular sides right here in figure R, that one right there, and then also this one right here. So it can be inverted like this. So I'm going to select figure R. Nothing in figure S. These are actually all obtuse. Now, I'm betting a lot of students got figure R. Here's the tricky part with figure T. This is arrow, right? This is really a heptagon or a septagon. I've seen it shown both different ways. This is a 7-sided shape. And those are actually right angles down at the bottom. And so those might be a little bit more difficult for our students to recognize because it's a non-traditional shape. It's an arrow, but we normally don't do much with heptagons or septagons. Here we have just a parallelogram. Could possibly be a rhombus, but looks more like a parallelogram. We've got some acute angles here, some obtuse angles here, and then we've got a trapezoid. Same thing, 2 acute, 2 obtuse, nothing right. So our answers are going to be figure R, figure T. This is a 2-point problem. So we don't get data as to what they chose. We just know how many students got 2 points, and only 39% of our students got both of these correct. But 40% got only one of them correct. So if you put those two together, that's a 20 and a 39. That's 59% correct. So this is going to be our 10th easiest, or tied for our 10th easiest. And we had 21% of our students get 0 correct. Like I said, I think this was the easy one. And I think figure T probably threw a few kids off because we don't do much with non-traditional shapes like that. We're used to looking at even this hexagon, right? For figure S, it's stretched out a bit, but it's a hexagon. Those are the ones we're used to looking at. So we need to give our students opportunities to practice with non-traditional shapes, finding these parallel or perpendicular sides. And obviously all of this rested upon knowing the definition of perpendicular, but that is part of that standard is looking at shapes and identifying parallel and perpendicular sides for 4.6D. For number 29, we are relating fractions and decimals. This is standard 4.2G. And much like the earlier problem, we have this 8.05 or 8.5. It is larger than 1. So we're going to need to make an improper fraction, right? So if we just know that, if we know that this is 8 wholes, and we know that if 8 wholes is going to end up being, looking at our denominator here, it's going to be greater than 1, it's going to be improper, right? We can automatically exclude this one because 85 hundredths is going to be less than 1. Now, maybe it's 85 tenths, we'll come back to that, but once again, we can get rid of this one. This is, again, 85 hundredths. So even if we know what is a proper and improper fraction, we can eliminate A, we can eliminate C, and then maybe it's this one. So we've got two different options here. Now, how can we figure this out? Well, both of these, look at this 85 tenths. So let's just build 85 tenths. Okay. So what I'm going to do is I'm going to write place value chart here. Okay, so there's my tenths place, right? And there's my ones place. Okay. So what I'm going to do is I'm just going to draw 85 tenths. Now that's 10 tenths. Instead of drawing 85, what I'm going to do is I'm just going to draw this box right here, right? And this box is going to be kind of like it's my 10 frame, right? So that's 10. I'm going to draw another box, pretend I broke it up into like a 10 frame, that's another 10. What I'm doing is I am just going to create these sets of 10. And let's see, I got 10, 20, 30, 40, 50, 60, 70, 80. So here's my 80 tenths, and then I can just draw an extra 5. Now, what we know in our base 10 place value system is that when you have 10 of something, it becomes 1 of the other. So I've got 10 tenths, or I've got 1 tenth, 2 tenth, 3 tenth, 4 tenth, 5 tenth, 6 tenth, 7 tenth, 8 tenth, 9 tenths. This 10 tenths becomes 1. This 10 tenths becomes another 1. And this 10 tenths becomes another 1, and so on and so forth. And so I've got 1, 2, 3, 4, 5, 6, 7. I've got 8 sets of 10 tenths. So that is going to become 8 ones, because each 10 tenths becomes 1. So I've got 8 ones, and I've got 5 tenths left over. So 85 tenths is the same as 8.5. So that's what we're looking for is D, 85 tenths. Another way to look at it would just be to write it like this. Right, here's your tenths place, here's your ones place. 85 tenths looks like that. You can only write one digit in each place value, so you just bump this 8 over, and it becomes 85 tenths. Either way works. Our answer here is D. And let's see how we did across the state. So we had 27% choose A, and that was our most incorrect answer. And we just see this 85 right there. We know it goes to the hundredths place, right? So there could be a little bit of mix up there, but there's 85 and it goes to the hundredths place. We had 10% choose B, 11% choose C, and slightly more than half, 52% of our students choose D. So this is our 15th most difficult or 15th hardest tied. And so let's just, when we're relating fractions and decimals, we need to move beyond proper fractions. We need to spend our time helping our students translate improper fractions to decimals and decimals larger than 1 to improper fractions, because that's what both of the practice problems on this particular STAAR test has been, improper fractions to decimals larger than 1. For number 30, we are looking at representing data. This is 4.9a. And as you notice, we've got 14 numbers here, and we need to find 2 representations that match that data. So we got some stem and leaf plots, we have some tally charts. So I'm going to build my own stem and leaf plot, and I can easily translate that into a tally chart. And I'm assuming here we're going to need one of each. So it looks like my stems are going to be in my tens place, right? Looking at my keys right here, my stems are going to be in my tens place. Leaves are going to be in my ones place. Let's just build that first. So let's build a stem and then a leaf. And so I'm going to have my 20s, my 30s, my 40s. So let's build my 20s because this can easily translate into my tally chart just by counting how many of each leaf I have. So 20s first. Let me just put boxes around them so I want to put them in order, but let's just put boxes around them so they stand out a little bit. And let's see. All right, so here are all my 20s. Looks like my going from smallest to largest is going to be 23. And then 25. Then I've got a 26. And I've got 27. And then two 28s. So I put the 8 twice, and then a 29. All right, so my 30s, I want to put boxes around them now so they stand out. It looks like my lowest is going to be just that 30, so I'll put a 0. I want to line these up here. I've got a 30, I've got a 31. What do I have left? I've got a 36, 34, and 32. So let's get my 32. Let's get my 34. And then let's get my 36. You see all the work that students need to do for this one. So quite a bit of writing. And I'm just going to leave my 40 and my 41 and 46 standing right there. So first off, I need a stem and leaf plot that matches this. And so if I'm looking at this one, I'm missing a 0 right there. And I'm also missing an 8 right there. So it's not going to be that first one. The second one is definitely not going to work. They just did one from each randomly. And so it looks like my third one is going to work. That matches. So I can go ahead and mark that. Now, once I've done this, getting my tally chart is going to be fairly easy because I just need to count how many of these I have, right? Because this is going to end up being 20 to 29. This is going to be 30 to 39. This is going to be 40 to 49. 1, 2, 3, 4, 5, 6, 7. So I need to do 1, 2, 3, 4, 5, 6, 7. And I got 1, 2, 3, 4, 5 on the 30s, and then 2 on the 40s. And so they're very, very similar, but you see we've got the correct number right there. We're missing one on that last one. So my options here are going to be option 3, right? Option 4. And so those are my correct answers. Now, how did we do? This is a 2-point problem, so you needed both to get it correct. We had 46% of our students get both correct, and we had 37% of our students get one correct, right? So if you add that 19 and that 46, I mean, you're going to get 65% correct. So that's pretty decent, especially for this complicated data. This was our 6th easiest item on the test, and it's a pretty fairly robust item because you had to translate the data into 2 different representations, the tally chart and the stem and leaf plot. So a lot of moving parts there, but we did fairly well on that in the state. So looking at number 31, we are looking at types of triangles. So this is 4.6c. And we have a triangle here, and we've got some angle measures, right? So we could try to draw this if we really wanted to. So I'm going to try to draw this, and it might be correct, might not be correct, but that's fine. I just know this needs to be big. This is going to be my K. I'm going to make this my L. This is going to make this my J. Wouldn't necessarily expect students to draw a picture. You don't need to draw a picture, but I want to just represent this. Because what we know is this 115, right, is greater than 90. So if it's greater than 90, let's reverse that. It's greater than 90. That means this is an obtuse angle. And if this is less than 90, both of these, then they are going to be acute angles. So I got two acute angles, one obtuse angle. So what do we know about this type of triangle? Well, this is going to be an obtuse triangle. So it's either going to be A or C. It's not going to be an acute triangle. We need an acute triangle with all three angles to be acute, and angle K is the one that's larger than 90. Now, why is it obtuse? Because I still have A and C to choose between, because exactly one angle is obtuse, or because all of its angles are obtuse. Well, just try to build a triangle with all obtuse angles, and you'll notice here that it's not a triangle anymore. I can draw a hexagon with all obtuse. It's going to be very difficult for me to draw a triangle with more than one obtuse. It's going to actually be impossible. So it's going to be A here as our answer. And let's see what we did across the state of Texas. We had 56% of our students get this correct. So slightly over half got that one correct. We had 14% get that. And what's interesting is we only had 11% get angle C. So we either knew it or we didn't, because the least chosen answer is the other obtuse triangle. So if we didn't do that, most likely we were just kind of guessing here. Because if we really were cluing in on that obtuse triangle, I would have expected C to be the most chosen incorrect answer, and maybe they just were missing the justification. So this one is difficult because there's no visual. I drew a visual, but students don't necessarily need to do that. We just need to really get our students to clue into these angle measures and just know the definitions of different types of triangles. And not only just know the definition, but think about these justifications, because that is also part of how they can explain why an angle is a right triangle, an obtuse triangle, or an acute triangle, or equilateral, scalene, isosceles. They need to not only be able to name them, but also justify why they are what they are. But this is slightly on the easier side. This is tied for our 13th easiest item. And so looking at our last item here, we are at number 32, input-output tables. And this is 4.5b. And we've just got these input-output tables. And we have a rule, okay? We have a rule plus 7. And so what we're looking for is plus 7 can be used to find the output for a given input number. So when they give you the rule, we're going in between the input and the output. So 1 plus 7 should make 7. 2 plus 7 should make 14. 3 plus 7 should make 21. 4 plus 7 should make 28. And as you can see, none of those work. What this incorrect answer is doing is they're doing plus 7 going down the outputs, but it says plus 7 can be used to find the output for a given input number. That means we're going side to side between the input and the output. So it's not A. 1 plus 7 doesn't get me 7. Plus 7 doesn't get me that. I'm not sure what we're doing here. This is a plus 6 all the way across. So that one doesn't work. Now, 1 plus 7 gets me 8. Okay. 2 plus 7 gets me 9. Yes. 3 plus 7 gets me 10. 4 plus 7 gets me 11. So I like C. Let's see what we have here for D. I'll erase all that. So the first one works. This is a plus 7. But now 2 plus 7 does not get me 16. And what this ends up being is this ends up being a multiply by 8. It just happens to work on that first one. So D is kind of a tricky one here. But how did we do across the state of Texas? Well, let me kind of get us there. And we had 30% of our students get this incorrect answer, A. That's the most chosen incorrect. Remember, this was the plus 7 on the outputs. So they just got it confused on the which direction the plus 7 was going to work. Our correct answer of C got 57%. So we between A and C, right? We were looking for that plus 7. We got 87% of our students between A and C, and only 4% chose D, because that didn't really trip them up, I guess. And so this is a tricky one for some of our students. It landed a little bit more on the easier side, and so this was the 12th easiest item. And we really need to help our students understand that when we have input and output in two separate columns, we're going in between the two. We're applying the rule in between the two, not up and down.